is go to your team V2, V2 team, go to assignments, and the assignments you have lab number 8, static balancing study of rotary system. Right? There you should see this assignment, and in this assignment this link is provided. Open that link and this page should open. Is everybody able to open that page? Yes, Varshil, are you able to open that page?
Yes, yes, sir.
Okay. Now here we will be studying about 1x vibration. It is the first natural vibrations corresponding to first natural frequency. So just you can go through the introduction. Um, so the description is given. I am not going to discuss that much in detail. Then you have theory. Again, just read through it. It is it just talks about what is the effect of unbalanced forces, and all theoretical things are explained. Right. So let's directly go to the procedure. Right. Now, so in this procedure, the how to conduct the experiment is given. All right. So what I'm going to do, it is a very simple experiment. So for this, following this procedure, we are going to use this simulator. Okay. So all of you click on the simulator and just click on allow. Go to simulator. All right. So this is the simulator. So here, so this is a what do you say, a disk on which some mass is attached, unbalanced mass is attached. Okay. Now here you can vary some parameters. So if you look at the, let's look at the procedure again. So in the first part of the procedure, uh, you are going to keep the radius same. Radius at first you are going to keep the radius same and go on increasing the RPM. So as RPM increases, the force centrifugal force will also increase. Okay. So I'm just going to show you the how to do that. So just click on apply start. So first radius of the eccentricity. Eccentricity is 25, and just click on apply start. Right. And once the steady state is reached, click on calculate plot. All right. So when you click on calculate plot, two plots are created. So the top plot is centrifugal force versus RPM. The bottom is centrifugal force versus mass. Okay. And now this is the first point. Now after that, click stop. Then increase the RPM to 2000 and again apply start and do calculate plot. So you will get a second point. All right. Again do stop, go to 3000 RPM, apply start, do calculate plot. Again do stop, go to 4000 RPM, click start, plot next. Stop, 5000 RPM, start, plot. Stop. Right. So the last is the 6000 RPM is 6000. Start, calculate. Okay. So for R is 25, you get this curve. All right. These are the various unbalanced forces, and the radius of rotation is 25. Okay. Now let's change this radius of rotation from 25 and directly go to 100. All right. And replot all the points. Plus start, calculate plot, stop, guys, start, calculate plot, stop. Start. Right. So as you can see, so what is happening? See, for R equal to 25, it is the first curve, and when you change the radius to 100, the curve just takes off. Okay, the rise is very steep compared to when the eccentricity of the unbalanced mass is 25. So when R goes from 25 to 100, this the effect of RPM on the centrifugal force produced or the eccentric or the unbalanced force produced is very steep with increasing RPM. Alright, so that is what you have to observe from this graph. Alright, so now you are not going to do the screenshot. See, for each of the RPM you are going to get the force. Alright, so this force you have to note down for like when first for 25 and then for each of the RPM what is the force. See, the force is given in this last row. Okay, make a table and draw the curve in Excel. Okay, don't take a snapshot, create a table and draw the curve in Excel. Okay, so for both R is equal to 25 and R is draw the curve in Excel. Any questions?
So for different values, we
You,
can
I cannot
change the
hear the
RPM and the
just a mic.
radius, right?
Hello, just a minute.
Hello, sir.
I have kept the volume low. Just let me check my. Yeah, go ahead. Yes.
So for different readings, we can change the RPM and radius, right? As per our convenience.
Yeah, I mean, what I would suggest is see first keep radius as 25 and take the 6 readings for 1000 to 6000. Okay, all right.
So
So
for both the radiuses, we have to plot in the same graph or different graph in Excel. Hello.
hello.
Hello, sir.
Yes, go ahead.
Yes, I was asking in Excel, do we have to plot both the both graphs in the same graph itself or in different graphs for both the radius value?
You have to superimpose both the graphs. Just as you superimpose over here, you have to superimpose them.
Okay, okay.
So this is the first part of the experiment. Now let's go to the second part. So in second part, here the RPM is okay. The second part we are going to keep the RPM at 1000, radius of rotation at 25. Okay, and now we are going to increase the mass. Let's just refresh this. Yeah, again go to simulate. Start. Just to start, calculate. Okay. Increase the mass to 50. Start. Change to 75. Start. I think I had tried it for a higher RPM. Let me just. All right. This is the part of, and now just change the radius to 100 and let's see the difference. RPM is same. Calculate stop 25. Stop 50. Start. Stop 75. As constant, and first plot it for 25 mm radius, then increase the mass, eccentric mass from 25 to 100. So you get first 4 points, then change the radius to 100 and plot the again plot the 4 point from changing the mass from 25 to 100. All right. So this is the second part of the experiment. Okay. So first part is for keeping the mass constant and vary the RPM. Second, you keep the RPM constant and vary the mass. All right. So you will get a So first case you have to plot the second graph. First case you have to plot the first graph, Fn versus RPM. Second case you have to plot the second graph, Fn versus mass. All right. Any questions?
Sir, we don't have to take the screenshot of the screen, right? We have to recreate both the graphs.
Just a minute. Let me just increase the volume. Yeah. Go ahead.
Sir, we don't have to take the screenshot of the screen, right? We have to just recreate both the graphs in Excel.
No. See, now I will tell you how to write the report. See, add this introduction. Okay. First write the aim of the experiment to study static balancing of rotary system. That will be your aim. Aim or objective it is given. Okay. In the objective, the object and aim are similar. So object is first do a copy paste of introduction, then add the objective, then you can add the theory. All right. So all these things one by one you have to compile in your Word document, then add the procedure. Okay. See these this type of graphs you have to plot in your Excel sheet. But I have told you what graphs to plot, so don't refer to these graphs. These are slightly different. So whatever we have discussed, you have to plot graphs is like this. You have to plot, but similar to this, force versus RPM, and see here the R is where it's something like that. Okay, so here like these two graphs should be superimposed. Okay, so Excel will do the curve fitting automatically for you. You don't have to use any other software.
Why we want two curves for each
Why
graph?
do you think? Why do you think want to? What is the reason?
To study the behavior
So
varying
that
the.
is the reason. Yes. So you have answered your own question. All right. So for first part, two graphs. Second part, two graphs, and then write the uh, results and conclusion. All right. So this is the experiment. This is the first experiment you are going to do. Any questions?
Sir, so do we have to upload the Excel or just do we have to take the snip of the Excel and then put it in the Word document?
No. Just do a print PDF of the Excel chart. You have to attach the table. Okay, when you are plotting the results, the results will be what? The two tables. Table for part A and a graph, table for part B and a graph. So that you have to compile in the Word document. Do a copy paste from Excel to Word.
Okay, sir.
Okay, so for both the parts. So that will be your results. After that, you can draw the conclusions. So last step will be to draw the conclusions on the based on the graph. Any questions? All right. Now, after I will give you 15-20 minutes to complete this work. Whatever is remaining, you can complete it later. Okay. Because I have to do the MATLAB part also today. The MATLAB Simulink part. That experiment also has to be done today. All right. So, how many students have MATLAB installed on the PC? Just raise your hand in the chat box. Only 7 students. That's it. 8. All right. 10. Okay. So sizable amount. At least 50% students have it. So those students who have the MATLAB installed on their PC, just click on the MATLAB and open it, and so that it will take some time for that to open. All right, and you can start with this first experiment simultaneously. Just hold on a minute. Okay, I will give you 15-20 minutes to complete the first experiment. In the meanwhile, those who have the MATLAB installed, just open the MATLAB program and keep it ready because it takes a while for it to open. Any questions?
Hello, sir.
Hello, yeah.
So for the second part of the experiment, we have to keep the RPM 2000, right?
Yes, you can keep RPM 2000. You can play around with the RPM. You can play around with the RPM. You can keep any RPM. Only thing is that the graph should be distinguishable. When I change the radius from 25 to 100, you should get a distinct graph. Okay, you can try it with 1000 also. You can try it with 6000 also. It's up to you.
So do we have to plot both the graphs of RPM and mass both for both the cases, or one for each?
No, see, in this case, the FN versus mass graph. See, there is no variation there. It is just vertically as mass is in, yeah, as mass is kept constant. There is just increase. There is increase in the RPM for each step.
Yes,
So that graph is not much. You cannot conclude anything from that. So in the
exactly.
first case, don't draw the FN versus mass graph.
Okay,
Okay,
and in
and
second case,
similar in second case you are keeping RPM constant, so you get for that just a vertical line as the FN is increasing. So again, you cannot conclude anything from the force versus RPM graph. So don't draw the second FN versus RPM graph for the second part. Only draw the FN versus mass graph.
okay, okay. Thank you, sir.
Oh, all right. So those who have opened their MATLAB, okay, you have to click on Simulink. On the home page, click on Simulink. See, do this thing in advance because it takes a while for it to compile the binaries since you are running it for the first time. Okay, and in that, click on this blank model. All right, so click on that and just keep it ready.
Hello, sir.
Yes.
Sir, do we have to page the theory also in the Word document?
Yes.
Okay. Okay.
All right. See, remaining part of the experiment, you can do it later. Those students who are doing going to do the experiment on MATLAB along with me, can you please again raise your hand in the chat box? Right now, I can see only 4 students. Varshil Shah, Nishan Thakur, Ramesh Sabre, Yash Thakkar, Siddharth Jain, Prathamesh Mehta. Anybody else who is going to do? Have you started the MATLAB program? Varshil, have you started the MATLAB program?
Yes, sir. We have started the new model in Simulink.
Are you able to see this window on your for the Simulink?
Yes, sir.
Okay, now
Yes,
also
sir.
click on the library browser. All right, so this browser should open. All right, and I have also provided a Word document in your assignment. To download this Word document, experiment number 7, force vibration MATLAB. I have also opened the document on the screen. So the title of the experiment is study force vibration using MATLAB Simulink. Right. So this is the all of you are able to see the Word document.
Yes, sir.
So this is a dynamic spring mass system performing force vibration, and we have already discussed this system in our what do you say, in our theory classes, and we have derived the governing differential equation for this. So I have written this in a specific format. I have taken all the terms other than x double dot on right hand side. So left hand side is x double dot, right hand side is 1 upon m into this term into bracket. Okay. So this is how I am going to uh, this equation is what I am going to use to enter the construct the Simulink flow chart. Okay, so this is the graphical representation of the system which we are going to build in Simulink. So anytime you have to develop a system in Simulink, first you have to create this block diagram. All right. So here you can see there are two integrators. So x double dot when it enters the first integrator, it converts it into velocity, and if you integrate it again, you will get displacement. Okay. So you need so first thing I need is these two integrators. So what I'm going to do is I'm going to uh, MATLAB Simulink window and go to this browser and go to continuous. Okay. So in continuous, you will see this block called as integrator. So just do a drag and drop of this integrator. Right. And we need two of them. Go to the window, continuous, and drop one more integrator. Right. And join this. All right, all the MATLAB students, are you doing it simultaneously?
Yes, sir.
Oh,
Sir, how to join?
just draw the arrow. Draw a straight line
Okay.
through the arrow. Automatically it gets joined. Just increase the size window. Oh. Done up till this?
Yes, sir.
So what next after joining these two blocks?
All right. Is everybody done? How many students are still doing this? Not completed this step. Out of the eight.
Almost done, sir.
All right. Now go to math operations. Now what we need to do is we need to multiply stiffness with displacement and uh, velocity with the damping coefficient. Here now one thing you need to note is that I have used a slightly different notation for damping coefficient. Instead of using C, I am using B. All right. So B is your damping coefficient. Okay. So B is to be multiplied by X and K is to be multiplied by X. So for that I need this block called as gain block. So go to math operations and pick on this gain block and just do a drag and drop it over here and just do a right click on that. Do a right click on it and just flip the block, okay, and join it with S. So this will multiply K with X and I need one more to multiply B with X dot. Okay. So again go to the browser and provide another drag and drop and then again do a flip and then join it with X dot. Done this step. User completed this step. Please raise your hand. All right. So 8 students are you doing. So all of you are done. All right. Now this is your stiffness. So double click on this gain and it will open this dialog box. Replace that 1 by K and click OK. Similarly, replace this one by B and click OK. All right. Now we need to add these two signals. So what we are going to do, we are going to sum it. Again, go to math operation and there is a block called sum. pick on that block and do a drag and drop over, right? And just move it over here and just then flip it. Flip block and just add. Done up till this? How many are still doing it?
Yes, sir, done.
All 8 students are done. If you're done, please raise your hand. One is still remaining. All right. Okay. Now I need to subtract these things from the, what do you say, the force. So I need another sum block. Just drag and drop another sum. And now this has to subtract it from 4, so that is another input. So for that I need a source block. So from this window I go to sources and I select a step input. Just double click on this block and change this to minus.
So the screen is paused, freezed.
Okay, just a minute. How about now?
Yes, sir, visible.
Okay. Done up till this?
Yes, sir.
Those are finished, please raise your hand. I can see only 5. Only 4. 5, 7, 7. All right. Now I have to scale this signal by 1 by m. All right. So again, I will need a gain block. So go to the browser window and go to math operations and now add one more gain block. Click again, drag and drop and add and do this. All right. All right. And just double click on this and replace this by 1 by All right. Now I want to see this whatever output I get. So for that I need to provide some sort of output device. So those are sinks. Those are called as sinks. So for sink, I'm going to select a scope, like the oscilloscope, which will show me the output. Now here in the oscilloscope, I want what do you say? I want two signals to be seen in. So I need to input two signals in the one scope. Okay. Now, but here, if you see the input, there is, I can only now right now I can input. I can see only one signal. Okay. So I want to see the input and the simultaneous output in the same scope, one below the other. So what I'm going to do, I'm going to go to this browser window and go to signal routing and select this bus creator. Get this bus creator and input it over here and take some signal from here, take it from here. And take another signal from that is the input. Right? All right. So we are done with the block diagram. Now let's go to the MATLAB window and define these variables. So I'm going to define m is equal to 10, and b is equal to 2, and k is equal to 5. All right. Now we'll run the simulation. And click the all right. So you have your input and output. This is the step function, this is the input, and this is sinusoidally decreasing output. Now, if you want a nice output in which you will be able to see things, you can just increase the time to 100, run the simulation again. The earlier graphical window. Click on scope. All right. So here you can see it is a step input and you have a sinusoidally decreasing output, which is similar to our underdamped vibrating system. All right, is everybody able to keep up with it? Any questions?
Sir,
So
what
can you
is
please
the
show
job?
the input again of the variables?
The values? Yes.
Yeah.
Just go to the MATLAB window. M is equal to 10, B is equal to 2, and K is equal to 5. Yeah, somebody else was asking something else. Varshil.
The same question.
Now I want to plot this result uh, using our regular MATLAB graphical functions. So I want to send these results to the workspace. So what I'm going to do, I'm going to go to sync, and select this block called sim out and do a drag and drop over here and take the signals from here and take it over here. All right. Ah, something happened. All right. Now run the simulation. After you run the simulation, go to the MATLAB window and just do a simplot out dot sim out. All right. So here you can see nicely. This is the step input function, and this is the output function. That is the displacement.
Hello, sir.
Yes.
Can you please repeat the last step after adding the out sim out
Yeah.
block?
Yes. That's that. So go to your the browser, and go to syncs and select this one, sim out, and just do a drag and drop. And just do a drag and drop from the browser to this workspace. Okay. Right. Delete this, and then just connect this to take branch it out over here and connect this to this block. All right. And then again run the simulation. Just to run. All right. Once it is done, go to the MATLAB and just type in simplot out dot sim out. Then you'll get this window. This blue is your input signal, and this sinusoidally decreasing is your displacement.
So can you show the Simulink window again?
Just Now, in addition to input and displacement, suppose I want one more. I also want to plot the velocity. All right. So just double click on this bus creator and change the number of inputs to 3. All right. And connect this thing to the signal coming out of this. And again, just run the simulation and again go to the MATLAB window. This out. All right. So now you are able to see the input force, the displacement, and the velocity.
So could you please show the Simulink window? Simulink window.
All right. So that's all. Now we'll just try to see some additional results. Now, what I want to do, all the students who are doing the MATLAB, see, I want you to do two things. First thing is I want you to change the parameters. See, I have used these parameters, right? So just go ahead and do a clear all. See, are you able to see this MATLAB window?
Yes, sir.
Everybody? Okay. Now in this, you're seeing this workspace small window, right? So in this, you have all the variables which we have defined, B, K, and M. Okay. So let's just flush them out first. So just do a clear all. It will remove all the variable. Now I want you to select any suitable variables of these M, B, and K. And now we have this system. What we have plotted is an under-damped system. Now, can you convert and can you adjust the variable so that we get a critically damped system? All right. So close this graph, close this graph, and uh, make a plot critically damped system. And once you get that, so let me just stop. Let me just stop the share. So I have done it on my end. So I want you to do something like this. Same. Can you see the screen? See, I have changed, and as you can see, now the system is now critically damped. See, the signal is going to it is dying down and it goes to some value. All right. The graph scale has to be adjusted suitably. That is why you are not getting that at 0. So I want you to adjust the system so that it becomes critically damped. And here is your step input. Here is displacement and here is velocity. All right. So do that and upload that. Now you can just what do you say? Save this file. Okay, just click on the save button and you should be able to save that as a save as.
Top right corner.
Pardon?
Sir, there
Yeah,
is
yeah.
a button on the top right corner with the symbol of a camera that will save it as.
You can take a snapshot of that. What is that? This one is okay. Okay, take a snapshot. Snapshot. Uh, and save. Just give some name. Force vibration, and then upload that figure in your force vibration dot. All right, upload this figure in your what do you say in your assignment.
Sir, so we have to only upload for critically damped and only for.
No. See, later you have to compile the entire report. For now, I want to do the evaluation. So for that, I need you to just upload the image for a critically damped system. All right, so 25 marks for this assignment. So 12.5 marks for this plot, that is this critically damped, or not 12.5, 10 points for this. And after that, you have to plot.
Sir,
Yes.
sir, I've uploaded. Can you please check?
Name? What is the name of the student? Ramesh Sabre.
Yes, sir.
Okay. All right. So how did you do it?
Sir, with equating the constants, both the constant damping coefficient and even spring constant.
Means damping coefficient
Uh,
is B.
yes, sir. So damping coefficient will be critically damping coefficient. So omega n, and omega n will be m by k. So I took mass as 10 and
So how
then
much did
k.
you take? How much did you take C, B, K, and M? What are the values that you use?
One second, sir. So B B is 40,
B is 40.
K.
Okay. Just a minute. Just a minute. Just a minute. B is 40. Then
K is 5,
K is 5.
M is 10.
M is 10. So what kind of system do you think you have got?
Critically damped, right?
Is it critically damped? What is
Let me
the
check.
equation of zeta? B divided by C divided by CC. CC is 2m omega n, right?
Right. Yes, sir.
Right, and omega n is K by m. So it will be 2 into square root of K into m,
Oh,
right? So
oh
that is the value
yeah.
of zeta. So what is the value of zeta? So what system have you plotted?
I did a mistake, sir. I took the
No, no.
omega n as
Okay,
M.
that is fine. That is fine. That is fine.
Mm-hmm.
Not an issue. What is the system that you plotted? Can you answer that? You are getting a result which is similar to the graph which I have shown, right? So why are you
Yes,
getting
sir.
it similar? Can you answer?
It's an overdamped.
Overdamped system. Correct. Alright. So if you check the zeta value, it is greater than 1. So okay. So that is also
One.
fine. Alright. No need to change the response. Okay. So what you have plotted is in fact a not a critically damped system. It is an overdamped.
Yes, sir.
Anybody else who has done? Now I want other rest of the other students to plot for critically damped, not overdamped. Overdamped response is done. The 8 students who have the MATLAB. All right. Now those now you have completed the first part. Now what I want you to do is go to the sources. Go to the sources and replace. So now here in your Simulink block diagram, you have step input, right? Okay. So we have used step input. Okay. So instead of step input, replace that with a ramp input and run the simulation again with the original parameters that I gave. All right. It is for the underdamped system. I give some values of B, K, and M, right? So use that values and plot the system. Replace this step input by ramp input. Ramiz, Sable.
Yes,
All
sir.
right. That is the task. Next task for you. Replace the step
Okay.
input by ramp input and generate the 3 graph for not for the critically damped system or over damped system, but for the under damped system.
Okay, sir.
And again upload your response in the in your what you say assignment window. All right, who are the 8 students who are doing the system on MATLAB? Please raise your hand. I just need to take a screenshot. The 8 students who are doing it on MATLAB, who are working on MATLAB right now. Only 7. Nine students. All right. All right. How about Siddharth Jain? Have you uploaded the output?
No, sir, my scope is not running.
What do you mean
trying
the
that.
scope?
It's coming grayed out, so there's an error.
All right. Siddharth, yes, Thakkar. Have you uploaded the output?
No, sir, doing.
Nishan Thakur, Prathamesh Mehta, Raghav Biani, Priyansh, Varshil Shah. What about you?
Sir, I ran the simulation before I could do anything myself.
Sir, I'm trying. The nature is not coming near to that.
How are you working out at critically damped?
So our critical time is zeta is equal to 1. So we have to equate
Equal to what?
2m omega n equals to c. That would be.
Huh.
And accordingly we have to solve.
So choose some value of m.
So
Choose
m
some
is
value of
25. So I took m 25, k 100 and b as 200. And I
No, 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 no,
solved.
no. See, a you have taken at 100, na?
Yes, sir.
And m how much you have taken?
25.
So square root of 25 into 100, 2500 is 50, right?
Yeah.
So twice of 50 is
Okay, I got it, sir. I got it now.
you cannot
Arre.
change.
So I
You
made
have
a
to
mistake. I got it.
derive the value from that.
Yes, sir.
All of you, I have just explained how to get the value of b, k, and m. How to set up the values of b, k, and m. So set up these values fast and plot the graph and upload it. Ramesh, are you done?
Yes, sir. I just uploaded.
Uploaded the second one also.
Yes, sir. The ramped one.
Sir, can you tell it again in short?
Zeta is equal to b by 2 into root of k times m. All right. So suppose if set some value of k and m and get the value of c, set that value of c as your parameter, and then you will get the graph. And run the simulation again and get the graph. All right. So this is good. All right. Now about compiling the report. So now all of you have this Word document, right? So you have to add stuff to this Word document. So this is theory, This is the block diagram, and then you have to create uh, uh, so whatever exercise we have done, for that you have prepared this block diagram. All right. So again, you can take a screenshot of this. Here, where is that? Yeah. See this camera button. So using that, you can take a screenshot. All right, of this block diagram. So when you take the screenshot, make sure that the entire diagram is incorporated. Zoom and pan it. All right. So take a screenshot of this entire block which you have done and give a suitable title, simulation block diagram for a force vibrating system or something like that. All right. So after this, you attach the block diagram. Okay. After attaching the block diagram, you attach the graphs that we constructed. The three graph, that is the graph for the step input, then the uh, displacement graph, and the velocity graph. All right. So first the Simulink block diagram, then the graph. All right. Then you have to plot the critically damped. You have to give the parameters for which you have selected for a critically damped system. Attach the critically damped system graph. After that, I'm going to give you one more task, provided you complete the first task, the one for the critically damped. All right. So Ramesh, you can simultaneously start compiling the report, and so that I get just a idea whether everybody has followed. All right. So start compiling the final report. Just download this Word document and add these things and submit it. I will give you, like, say, once you're done, just let me know. I will check.
काय जो आहे त्याची बॅक कटिंग मशीन वॉलपेपरवरती
Hello, sir.
Yes.
So, I just wanted to know that which all snapshots do we have to enter?
Just
The
a minute.
block
Just a minute.
diagram for that?
Yeah, go ahead.
Yes,
Yes,
sir, I was
somebody was.
asking. Yes, sir.
Yes. Yeah.
So, in the MATLAB compilation
Huh.
for experiment number 7,
Yes.
after entering the block diagram in the screen where you are right now, what
Uh-huh.
else do we have to enter? Like, which all
You have to
snapshot?
the output of that output window with those three graphs: step input and displacement and velocity.
Okay, so, that should we do that from the scope or from the MATLAB window?
No. The sim out thing we did, right?
Yeah, exactly. So from the
Uh,
MATLAB window, right?
yes.
Okay, sir. So these two only screenshots, right?
And plus
Critically damped.
critically damped. And one more thing is there. So once you have completed the critically damped, then I will give you the remaining things.
Okay, sir.
Now for the students other than these 8 students who are not doing this thing on MATLAB, so what they have to do is they have to solve for the same system. Okay, so they have to repeat the entire steps assuming that the system is undamped. All right. So design all these things, the governing differential equation, write it, then draw this block diagram. You can draw it using pen on a plain paper and scan it and upload it. All right.
Sir,
Yes.
sir, can you explain the critically damped part again?
See what is just a minute. Just a minute. Let me complete this first thing for the students who are don't have access to MATLAB and are not doing it in on MATLAB. So what they have to do is to replace this entire experiment part by uh, make the system assume that the system is undamped. So B is 0 for you and accordingly modify the entire experiment. Okay, so this will be 0. Then again redraw this diagram. You can draw this diagram using what do you say, using your pen. All right, so draw this diagram manually and then also make this Simulink block diagram. All right, you don't have to actually do the experiment in Simulink. You can just draw this Simulink block diagram only by modifying this diagram for undamped system. So B is 0 for you. Is that understood? Other students, who are those students? Let me just see.
Yes, sir. Yes. But sir, what about results?
Results you have to generate that results in for. So what now so step input and all those things will be difficult for you. So now you have to use, so for you can use the sinusoidal input, sine wave as the input. All right, and draw the get the results in Excel and plot the three graphs of that is the force, input force, and displacement and velocity. All right. So these curves you have to MATLAB for a sine wave. All right. So it's a similar thing you have done in your assignment also. So you can take reference from that and just draw the graph for for input, displacement, and velocity using Excel sheet, or if you don't have access to Excel sheet, just do it on a plain graph paper and attach it.
Okay, sir. Okay.
So can you check mine? I have uploaded it. Prathamesh ma'am.
Somebody was asking about a critical reversal.
Yes, sir.
Did you figure it out, or
Sir, we can take any value, sir.
okay?
We have to
Let me just explain to you by using this example. So what are the values you have taken for B, K, and M?
So for M it is 25. For
M is 25,
K is 100
K is
and B is
100.
also 100.
Sir, I have also uploaded for critical
Yes,
damping.
sir. Okay, so this is okay. All right. So now
Okay, sir.
just hold on a minute. Which one? Who is the other one?
Nishant Thakur.
Shan Thakur. Oh, you are using a different version of MATLAB?
No, sir, I snip the scope.
No, don't do the scope, because see, in scope everything is getting mashed up. No, that is why I asked you to do the sim out thing. So do it in sim out.
Okay.
Anyone else who has submitted?
Sir, do we have to include the ramped input in the this thing file?
Who is that,
Final.
sir? Ramesh?
Yes, sir.
Yes, yes, you have to include that. All right. Now, after you do the critically damped input, now the second part, I want all the 7 students who are doing it in MATLAB. All the 7 students who are doing it in MATLAB, where are those students? 7 or 9? How much? How many are there? 9. All those students who have raised their hand in this, showing it on the screen. All right. So for them, I am going to give one by one the various inputs that you have to take. So just make a note of it.
Sir, for critically damn, can you please ask?
All right. Just a minute. Let me just now give this assignment to everybody. Or Rami Sabre already I have gave. Siddharth Jain. All right. You have to select the repeating sequence as the input.
Okay, sir.
Yash Thakkar, use the pulse generator.
Okay, sir. So, what parameters do we have to take in that?
You can use the same parameter as earlier, or you can just change it.
Okay.
But the system should be under damped,
Okay, okay.
or you can use the original parameters which I used in the demonstration.
So we have to add this below the critically damped part in our Word file, right?
Yes. Yes.
Okay, sir.
Sir, so
Yes.
just to be clear,
Uh,
we have to put in the one for a step and then a ramp and then the one you are giving us.
no, step, critically damped, and the one I am giving now.
Okay, sir. Okay, sir.
3. Three graphs will be there. All right. So yes, who was I? Yes, Takkar, I have given pulse, na?
Yes, sir.
Nishant Thakur use the ramp. Nishant Thakur do it for the ramp.
Okay.
Prathamesh Mehta again sine wave. Raghav Biani use the pulse generator.
Okay, sir.
Use the ramp. Rushan Mawani repeating sequence. Varshil Shah use the sine wave. All right. Anybody else who has not, I have not mentioned. All right. So your report will have these three graphs. First graph is what I have given for the part which I have done. All right. So for that you have to include the Simulink block diagram and the graph. Then you have to draw the graph for the critically damped system. After that, now whatever signal you are going to replace that in this block diagram. Again take a snapshot of that. So for the third part you have to show the Simulink block diagram as well as the output corresponding to it. Okay, so block diagram should be also included since the block diagram is being changed. Correct. So all these things should be there in this report. So start compiling the report and upload it. The other students who are not doing it in MATLAB, start compiling the report for the first experiment which we have done today and upload it. I will take attendance at 3:10.
Hello, sir.
Sir, we don't have to upload any MATLAB files, right?
Somebody was asking something.
Sir, we don't have to upload any MATLAB files, right?
This is the MATLAB file, the block diagram.
No. So
Block,
only a screenshot, not the MATLAB file.
yes.
Yes. Okay, sir.
Sir, I've uploaded the report. Can you please check?
Who is that, sir? Ramesh?
Yes, sir.
You have uploaded the entire the PDF document. Oh, so you added the critically damped also. Good, good. Okay. See, only one thing I have added, that is the for the ramp input. Since we are changing the block diagram, make sure you also add the block diagram also. All right.
Okay, sir.
Okay, since block diagram is being changed, just add the block diagram also. That's all. This is good.
Sir,
Right.
even I uploaded Yash Thakkar.
The entire report,
Yes, sir, the one with pulse generator and all, like as you
pulsion,
mentioned.
just the diagrams.
No, the entire MATLAB experiment.
Means the Word document you uploaded.
Yes, sir.
Okay, this is also good. You can also mention the parameters which you have used. So for the critically damped system, what parameters you have used? It is B, K, and M. Your values you should also include in this report.
Oh,
Alright.
okay.
So
I'll
for
re-upload.
critical right, just enter those values.
Yes.
This is okay. What about others?
So can you check mine,
Who
Siddharth? I've uploaded the
uh,
images, not the entire doc.
now don't upload the images, just upload the entire report now. The other
Okay,
students.
sir.
So we have to write parameters just for critically damped or for all the three parts?
You can write the parameters for the ones which part which I have done along with the units and the critically damped. Only these two.
Okay, sir.
Only there are two instances, right, where the parameters are being changed.
So the
For the
first
pulse,
one you did, so in that the ones you took, and then for critically damped, and then for the pulse generator,
the pulse
like the
generator.
third.
If you have varied the parameters, you can yes, you can write all three instances. You write the parameters. So some of me have varied the parameters, so you can include that parameters also in that.
Okay, sir.
Sir,
Yes.
sir, for the first experiment, what do we have to write in the result conclusion?
Result and conclusion: the behavior of a forced damp vibrating system for various types of input under various operating condition was studied. Like that, you can write something like that to that effect in your own words. You can write. There is no results. Results are what are displayed in the graph. So just write the conclusion.
Sir,
Yes.
sir, for critically damped zeta equals to 1, so 2m omega n equals to b. So
Yes.
omega n root of k by m. So
Yes.
we have to select values of k and m, and the answer which we get from that, it will be the value of b.
Yes.
Okay, sir. So if I take 50 as m and k as 25, so I get b as 70.71.
As far as possible, choose values so that you will get a perfect root, so that it will be easier for you to input.
Okay, sir.
Huh? भरलं का त्याच्यामध्ये?
Hello, sir. Hello, sir.
Yes, go ahead.
Yes, I was asking for the experiment 8. Uh, uh, After plotting the graph in the in Excel, do we have to take a snip or do we have to take by choosing the print
No,
option and
no,
then
uh, just do a print PDF, na.
okay, sir, and then we have to add that to the
Ah,
Word document.
you can add that. You can convert the entire report into a PDF and attach that.
Okay, so we have to attach the two PDF separately, apart from the original document of the experiment.
No, just merge everything together. Don't do separate. The final report should be a one consolidated report. If you are not
Okay.
unable to manipulate it using PDF, just take a screenshot and you can do the paste in Word also. That is also fine.
Okay,
But
so thank you.
everything should be compiled together. All the reports of the for evaluation purpose, I am asking some of the students to submit, some graphs, some figures separately. But at the end of the experiment, you have to prepare one consolidated report, which has to include everything which has been discussed during the experiment. Uh, Lab number 7 is MATLAB Simulink. Lab number 8 is the balancing experiment.
So we can submit it today, right? We don't have to submit it right now.
No, you can submit it later also.
Okay.
Sir, hello.
Yes, just a minute. Let me just first copy your attendance sheet. Yes, go ahead. Yeah, you're asking something.
Sir, I had a doubt in the governor's experiment.
Yeah, go ahead.
Sir, in the videos, we are observing the lift of the sleeve, but
Uh-huh.
we have to plot height of the governor versus the RPM.
No, no, no. So, yes, that is correct. The what we are doing in the simulation and what we are doing in the experiment is slightly different. So here, that we are not plotting the height of the governor. We are plotting the sleeve displacement. Okay. So that curve will not come similar to the one which is there in the similar. It will be like a mirroring effect. It will come exactly opposite because h increases as RPM increases. So accordingly, you have to draw. So that thing has. I would like to clarify that thing to all the students. Uh, that the graph will not be similar to the one in the simulation. That was the doubt, right?
Yes, sir.
Okay.
Thank you, sir.
Anybody else has any questions?
Yes,
So in
sir. What do we have
experiment
to?
8,
Yes.
so in experiment 8, we have to write any result or conclusion after the output.
Yes, conclusion you can from the behavior of the graph you can whatever you infer about the unbalanced forces, you can write that. Any other questions about any other experiments or anything else?
Once again, can you please explain that undamped part?
Which part?
Sir, the ones who are not doing on MATLAB.
See, zeta is equal to 1. Alright. And zeta is C by Cc. And Cc is 2m omega n. Right. And omega n is k by m. So zeta in fact becomes C divided by 2 into square root of k times m. Alright.
No, sir,
So
but
for
in undamped, how will zeta be there?
in undamped,
There is no zeta, na?
why? Undamped. Yes, undamped there will be no zeta.
For the ones who are not doing on MATLAB, you told to modify the uh, things for undamped system.
Yes. So B will be 0 for them.
Sir, so the integrator part of the B will not be there, right?
Yes, you have to modify that part.
Okay, sir.
Alright. So that simulating diagram you should have to prepare accordingly.
Hello, sir.
Yes.
So I have uploaded 8th experiment. Could you please check?
What is the name?
Prashant Kadam.
But Prashant Kadam, you have not raised your hand.
So 8th experiment. So 8th.
Got it. The balancing one.
Yeah.
See, when you do a copy paste, see the theory is coming on one page, but actually theory is starting on next page. So you should adjust it to move that title theory on the next page where the theory actually starts.
Okay, sir.
And see, when you're doing that copy paste, see the spacing between the paragraph is very large. Okay. So that comes as a default when you do that pasting. So just delete that unnecessary space.
Okay, sir.
Okay, again on the see steps and all. See, the report becomes too large. Okay, now at the in the steps, see they have plotted some graph. Have you selected the relevant one that you are going to plot? Okay, this is your graphs, the end at the end, right?
Yes,
The
sir.
observation.
Yes, sir.
Okay, those graphs looks good. So everything else looks good, and just so no. Otherwise, this report becomes 20 pages, which is not too long. So you can just there are so many unnecessary blank spaces in the entire write-up. So edit this whole write-up when you are doing a copy paste, and that unnecessary spaces you can remove it.
Okay, sir. I'll modify.
Uh, Otherwise, the other things are okay. The graphs also look good, and have you written the conclusion?
Yes, sir.
See, now whenever you are writing any statement, no, you have to be very careful. Huh? So, is it increasing linearly? I don't think so. What is the equation? FC is equal to FC versus mass. Okay, okay. ठीक है. Yeah, it is a linear relationship. FC is equal to
MV
M.
square by.
Okay, but now here the first one, second statement is fine. First one, it's you're saying that it increases exponentially. So when you say exponentially, it should be e raised to something. So the equation is not exponential. It is in fact a parabola.
Parabola. Sorry,
So
sir.
it is parabolic. So you can say it increases, but exponentially that term is I don't think it is appropriate. So increases to the power of 2 like that you can say, or you can say that the variation is a parabolic curve like that you can something like that. You can say.
Okay, sir.
I think rest of the graph is okay. All right, we'll if there is nothing else, we have almost passed the time. I just stop the recording.